My name is Mandar Muzumdar. I'm a postdoctoral fellow in the laboratory of Dr. Tyler Jacks at the Koch Institute of MIT. Our laboratory specializes in the development and characterization of genetically engineered mouse models of human cancer that closely recapitulate the human disease. I'm actually a clinical oncologist specializing in gastrointestinal cancers. So I have a special interest in improving the understanding of pancreatic cancer and applying it to improve both early detection, chemo prevention, and therapeutic strategies in the disease. Well, pancreatic cancer is one of the most challenging cancers that we in the field of oncology have to face. We have a tremendous difficulty in identifying the disease early in its course, and as such have also had a significant difficulty in being able to treat the disease. So the model that we use allows us to make genetic changes, allowing us to alter the cells with cancer-relevant genetic changes, and be able to mark those cells with fluorescent proteins. The image that you see actually depicts isolated cells in the pancreas that are labeled with different fluorescent protein markers. And each of the cells of different color actually harbor alterations in their genetic makeup. It allows us to then track these cells with a particular genetic makeup over time to see the full course of tumor development, from these normal appearing cells to later stages of cancer development and even to metastasis. So this first image that you're seeing now is actually the first of a series of images that we have taken in analyzing these mice. And this is when the pancreas is normal and we've made genetic changes, but there hasn't been any consequence of those genetic changes up to this point. Over the ensuing weeks, those green cells in this image will actually start to form early stage tumors that we can visualize using the similar techniques that we used in this case. And then as we wait a few more weeks, those green cells will then start to grow and take over the majority of the tissue around the pancreas and in the pancreas. And we can observe that with large tumors that are actually grossly visible within the mouse. So when we look at the mouse tumors, pancreatic tumors, they actually look very similar to what we see in the human disease. They actually behave very similarly in how they spread and how they grow. And they actually respond to chemotherapies in very similar fashion to how the human tumors do as well. So we think it's actually a very good model. We hope to improve the therapeutic options by understanding the molecular pathways that are involved in how these cells grow and develop. So if we can understand that using these model systems, perhaps we can intervene either early during the development of the tumor or even later on. We hope the model systems will identify new targets for therapy, for which we could use existing drugs if they're available, or develop new drugs to try and hit those targets.